Okay, class, we're going to do question 2, chapter 6, Sp2. In order to do that problem, let's take a look at the example 6.2 on page 107. This example says we have a box starting from rest on a frictionless floor, so we don't have to worry about the floor. You move a 100 kilogram crate by applying a net force of 50 newtons for a time of 4 seconds. This results in this final speed of 2 meters per second. I'm just reading what the author said here on page 107. And it also moves at a distance of 4 meters. So we have a force of 50 newtons. Well, question A says, what is the work done? The author said we had a force of 50 newtons, that it moved a distance of 4 meters. That's all given. So you want to know what the work is done. Well, work is force times distance. Remember, force parallel distance. In this case, the force is parallel to the distance. So you plug in 50 for the force, 4 for the distance. So we come up that our work is 200 joules. That's all done in the textbook. Question B says, what is the final kinetic energy of the crate? Well, the box started from rest, so the initial kinetic energy was 0. Work gives you the change in kinetic energy. Well, the work done was 200 joules. If the initial kinetic energy was 0, because the box wasn't moving, and the change was 200, then the final kinetic energy is 200. And now we can go to the problem, the second problem, Sp2. Sp2 was related to that example. So, as described in the example of box 2, a 100 kilogram crate. So this is number 2. A 100 kilogram crate. Slide along a frictionless floor. 100 kilograms. The crate is accelerated by a net force of 50 newtons. So the net force on the crate is 50 newtons. Now the author doesn't say if it's being pulled or if it's being pushed, then it doesn't matter in this case for this particular problem. And that 50 Newton force is applied for a time of 4 seconds. Question is, what is the acceleration of the crate from Newton's second law? So they want you to do it using Newton's laws. Well, we have F net is equal to ma. F net is given 50 newtons. The mass is 100 kilograms. So what is A? One equation, one unknown. We can see that A is equal to 50 divided by 100 is a half. 0.5 meters per second squared. Okay, B. If it starts from rest, how far does it travel in the time of 4 seconds? Okay, so if it starts from rest, which is what the example said, we know what our acceleration is from the previous part, 0.5 meters per second squared. It wants to know how far did it travel. Well, we also have the time. Time was 4 seconds. That force, the 50 Newton force that's accelerating it at this rate, continues for 4 seconds. The author wants to know how far did it go? How far did the crate move? How far did it go? So we can use our distance formula. Delta D is equal to V0t plus 1/2 AT squared. Plug in how far did it go? That's delta D. The initial speed is 0 plus 1/2. The acceleration is also a half times t squared. Well, t in this case is 4, and we're going to square that. So we get delta D is equal to half times a half is a fourth, cancels one of those fourths, and we have 4 left. So the distance is 4 meters. That's how far it went. How much work is done by the 50 Newton force? So that's part C. How much work is done? Well, we know work is equal to force parallel distance. The crate is moving in the direction that the force is applied. So we have the force is 50 newtons times the distance. We just found that was 4 meters. 50 times 4 is 200. Newton times meters is Newton meters, and we're calling that a joule. So the work done by the force, by the net force, by this net force, the work done by this net force is now 200 joules. Part D. What is the velocity of the crate at the end of 4 seconds? So the formula we have for that, again, we could do it 2 ways. We can use Newton's handy dandies, or we can use the work in theorem. So what we have is the work net is equal to the change in kinetic energy. But we know in this particular case that the object started from rest. So we know the initial kinetic energy is 0. Therefore, this is just equal to the final kinetic energy. And the final kinetic energy is equal to, we want the speed, so we put in 1/2 mv squared. The net work done is 200 joules equals 1/2. The mass was given to be 100. Just double checking that. Yep, 100 times v squared. We want to know how fast it is, so v is our unknown. One equation, one unknown. 1/2 times 100 is 50. Divide both sides by 50. We get that goes to, implies v squared is equal to 4. So v is equal to 2 meters per second, which is what we were told. Okay, and then finally, part E. What is the kinetic energy of the crate at this time? Well, we already know what the kinetic energy of the crate is, but we'll do it anyway. So E, kinetic energy of the crate at this time when it's moving at 2 meters per second is equal to 1/2 mv squared. That's equal to 1/2. The mass is 100. The velocity is 2, but the velocity is squared, so it's 2 squared. This half takes out one of those 2's. You still have 2 left. 2 times 100 is equal to 200 joules. That's equal to the final kinetic energy. Okay.